Okay, great. So, welcoming you all for this wonderful channel. Let's crack GATE and ESE Mechanical. So, I am Vivekanandan R, a verified GATE educator in Unacademy with a new getup today. With some prayers, I've just went to temple. So, this is where you can see the getup I have just on shirt. It's nice to interact, and people, if you are watching the class, I can see that people, the students, the aspirants are really inclined towards the sessions. I could see many people joining, but today is an early session because I want to connect with you at the earliest. That made me start the session now. So there are like many people here. Welcoming you all for this session, guys. So today the topic of discussion will be gating design. Guys, I have been handling a series of lecture in a short and sweet way because it's all about the quality of content. If it is presented in more meaningful aspect, we are there for it, correct? So with that note, I have to say, from the terminologies, the casting terminologies, to the pattern, the types of sand making, the pattern making, the types, materials, pattern allowances, the properties, the additives used in sand, etc. And to solidification and cooling was our fifth class. Fifth class happens to be riser design, and the sixth class now is on gating design. So upcoming classes, I will be completing the numericals, and at least the numericals will take 2 to 3 sessions in the days to come. Okay, at least I'll start with one session. Before that, I may complete casting defects. Yeah, casting defects, if we complete, that will be more handy. It's a complete notes, will be available with you guys. Okay, just make a note of it. If you are interested, you can just chat here. I request you people to make the chat box filled with messages to interact better. So I am a top educator in a GATE and ESE Unacademy platform, as I want to convey. So verified GATE educator, 9 years of teaching experience, GATE cracked 3 times, and I have cleared even IBPS. I was a former Indian Overseas Bank employee. Versatile. Have tried different things. AFCAT I have cleared. TRB Polytechnic lecturer exam, which means I am a person who has qualified to teach the students in the government polytechnic college for the mechanic department. Okay, so this is all about me, the basic stuff. So about the plus subscriptions, we all know the classes are live. People don't get confused between the online classes to the live classes. Okay, online class, live class is part of the online class. Even a recorded version of the online class would be available. You need data for watching it, correct? So please make a difference of them. Okay, and you have the weekly test, but the most important thing is when it's a live class, it's a structured course. Okay, it's a structured course for you all, my dear people. Okay, and it's unlimited access for you available. Please make a note of it. And experts guidelines are here for your reference. Okay, sir, this unlimited access is for the whole content, which is in a structured way. You'll be given weekly test, you can even have notes. But iconic subscription is for a student where you, along with the plus benefits, you have a personal guidance and personal mentor will be allocated to you. A study planner will be customized, made for you guys, and analysis will be done. Not only the weekly test that you're going to attend, even you will be given analysis and the guidance from all the top experts from our team, and the study material will be available. Even physical notes will be available for the students. Please make a note. So you can use the code VivekGate20 to avail this offer. Please make a note of this, right? And the price hike is coming soon. I have to inform you that when you use the code VivekGate20, you can even save a lot with 10% offer, and also you can overcome the price hike issue. Price hike. And this is a very important point for guaranteed scholarship test, the Unacademy Major League Combat 2.0. This you can attend both in Android app as well as the web. It's a live test, so you also get gift cards, Okay, other vouchers you can see here, the hint of it might be a MacBook like the earlier time, iPhone 11 I believe, and the tab to Amazon gift vouchers. Okay, so these are the benefits that you can avail. So you can enroll now completely for free. You can also bring your friends. Up to 200 students, the scholarship will be provided. So why you are wasting the time, guys? Please enroll sooner. Department wise, there will be 20 questions. A department specific question you have to answer in 60 minutes. See, these Amazon vouchers or whatever that are coming as a gift cards will be all for the students who are attending the 20 questions completely. There you will be taken in the lot and you will be awarded. So you are a lucky participant, you will get that. But when you are a student who are in the top 200 ranks, you are a guaranteed scholarship holder. Then you are standing a chance to win so much of scholarship. Okay, that is something to be happy about. So this is for the one-on-one live mentorship, the iconic subscription. So we'll discuss about this in the upcoming slides. We'll initiate with the questions now. Topics. So students, when we talk about the gating design, remember the diagram. Okay, so here you can see right. So this is points we are calling about. Okay, I will highlight the terms. My method of teaching always used to be with diagrams drawn at that moment. Okay, not to bring any kind of an images. See, this is how the usual casting would be. But more than that, my dear students, if I draw one more figure, you will understand how different the diagram could be. Okay, how different the diagram could be. Okay, this is how we usually draw a diagram, correct? But my dear guys, in a gating design, when we say particularly, it has small changes in it. For the comparison, I am drawing a second diagram and not to overlap on the previous one to confuse, but to get the better clarity of it, I am drawing it here. So there's a small change, as I say, there's a dip. So this is it. So we will be having a strainer, okay, a porous member which allows the material to pass through the molten metal, and also a splash core. We will be discussing their purpose here as well. So you can see a small change in the presentation of the setup. Rahul sir, good morning, and hi Shambhu Kumar Bhartwaj. Good morning. So I handle the classes of general aptitude as well as a mechanical engineering faculty. I am sir. Rahul, I'm really happy for that you are able to recognize that. And most importantly, I handle the classes in English and Tamil, and I can understand Hindi, but I'll be communicating back in English only here. So these are something about me I want to share with you people, and thanks for that message, Rahul. May I know a few words about you? Which college, which year you are studying, and which department? Probably being mechanical, I think you are here. And Bhartwaj to which college and which year you are, sir, and which department? Maybe production, industrial, mechanical. Of that sort, I wish to hear from you people. Okay, so back to this. Let me discuss. So students, this is what we call it as the pouring basin, right? The vertical member is your sprue. All these basics, I think we have discussed in the previous classes. I used to say between runner and riser, by any chance if you make a mistake, the runner is one that is a horizontal, where you run on the horizontal platform, where you raise it, no, it rises. We say the temperature rises, you can easily see it in the vertical order. So you can easily remember the riser is always a vertical member, and there is always a one here. That's nice of you, Rahul sir. Fantastic. Thank you so much for that. So I used to handle the classes. I've just started the course on joining process in the plus part in Unacademy, right, sir? So followed by all the mechanical engineering subjects on the manufacturing, followed by industrial engineering I'll be handling. So students, right from the very basics, without a knowledge, like zero knowledge, if you are entering as a clean slate, I can easily make an art out of it, the best content for you guys. So there is a shortcut in the gating design I want to tell you. They used to ask a question here. They used to ask a question here, so you can make a note of it. So runner, and this is the in-gate, right? These are the things that we can see. But you can see here a small shallow portion being cut out in the runner, and that green color part we are calling it as splash core. That is a splash core. And from the top you can see this in the pouring base, between the pouring basin and the sprue, we are calling it as the strainer. And here you can see a shallow portion on the bottom and top. These are called your skim bob. And this is your in-gate after that. Okay, this is what we have to say here. Please make a note of it. I do, sir. I do teach them there. Okay. For now, I am more concentrated with manufacturing, IUR and aptitude part in general, and followed by the design papers, HMD2. So with the students' demand, I am going with here, sir. When you are also part of it, definitely I will be doing it, Rahul. Glad that you are aware of me, and please follow my profile in Unacademy as well. I'm going to come up with a series of classes, and the plus will be so awesome, sir. I think it's the right time to start. So skim bob, splash core, strainer, and etc. Okay, so let's move on with them. What is the pouring basin, sir? It is the opening in the mold through which the molten metal enters. Correct? If I present the terms, let me write it in a new page. Okay, or here we can write pouring basin. It is the opening in the mold. Just on the mold, it's an opening through which the molten metal enters. And pouring basin ensures the flow of metal into the cavity, right? So opening in the mold through which molten metal enters. Through which So what is the strainer then? What is the use of that strainer? Sir, it is a filter, okay, made of ceramic material with a high porosity. It is helpful for separating the impurities in the molten metal. Separates impurities in molten material. Separates the impurities in the molten material. Okay, and it's a ceramic of high porosity. You can write this information, ceramic of high porosity, you can write. So these are the terms that we all have to note down. Okay, so this is about the terms. Okay. Why did you track the message? Okay, fine. Regarding the sprue. So sprue is a vertical member that is connecting the pouring basin with the, simply we can write connects pouring basin with runner to the runner. Correct. It's a vertical member. I hope my it is not going to hide those lines. Sprue. Okay. The most important thing is it is a straight and let's do this line. It is a tapered circular cross section. It is vertical, but it's a cross section. Okay. I do, sir. Sambu. Regarding you, Shambu, would like to know which department and which college, sir, to understand. Okay, sir, there is an important note here. Why the sprue has to be tapered? Such an interesting line. This sprue, to be of a tapered cross section, has a greater effect in producing a sound casting, a defect-free casting. This crucially plays a role. Why? Why does it need a tapered cross section? Sprue need a tapered circular cross section, not a straight one, but a tapered. See, obviously you have to draw it tapered only. Okay, tapered cross section instead of a straight one. Okay, perfect. To avoid aspirations, you say, exactly. So few students need to understand. Sir, my way of teaching used to be like this, Rahul sir, and for Shambu to all. You might be somebody say right now, since Bharatwaj or some other students who are here doesn't interact. I don't know where they stand in their preparation in metal casting. And for many colleges used to give only the basic content, not the numerical part. Right? My classes in the days to come will be more of numericals. Yes, short sessions, say 2, 3, 4, 5 questions maximum will be discussed in the day order. So please make a note. So some students will not be knowing anything from the subjects, so they need it from the basics. Somebody will be like, sir, I'm only looking for that additional content, sir, because I'm good at the basics from my college side. I am very much interested, so I prepared well. Additional, say some numerical questions, previous year practice questions, and everything. When I say previous year questions, I have handpicked majority of the questions from all the competitive examinations. I have segregated them as a topic wise, subject wise. Okay, so my way of teaching always would be from the basics. If someone answers it, I appreciate them, but I have to give the content for others, because as a teacher, it is my duty. This is how I used to teach people. Got it? So I'll always teach from the basics. So for these students, I'll give them the best shortcuts and the numerical. So I'll lift these people to the next level, and from here on a whole, I will take everyone over here. Okay, on a whole, I will be taking everyone. Please make a note of it. Please make a note of it. Right? Now, sir, what is the need? This is the need, sir. If the sprue is straight to the sprue is tapered, the benefit is when you pour the molten metal, if you assume a tumbler, when you pour the water, you know it will be taking this position, right? This position, correct? So when it is being poured in from a ladle into the pouring basin through the sprue, it will pass in this direction. So remember, it just falls in like this, correct? This is how it will fall. So if it goes in here, completely fills. So this is how it goes. So remember, at the bottom when it interacts with the sand that is in the runner, actually the runner is all made of sand, there will be some organic substances. So automatically what happens, the molten metal when it reacts or interacts with the organic substance in the sand, the gases that are produced, right, gases that are produced cannot escape, but here they can. So this is what we call it as the aspiration effect. Otherwise what happens, the gas remains within the cavity and it can form porosity, it can form the bubbles inside it, and definitely the casting will be all of defects. So these are the reasons, my dear people, the sprue is made of tapered cross section. So what is the benefit? To escape the gas, to avoid aspiration effect. Correct? We have to use the correct perfect lines. These are simplest ones. Thank you so much, Shubham Kumar sir. Fantastic of you. To escape the gases so that it can avoid the aspiration effect as well. Hope it is loud and clear to you all. That's nice. So students, I have a shortcut to say, share with you, but let's proceed further. Sir, so we have understood what is meant by a sprue, correct? So further, let's move on with the splash core. You know where is the splash core located? Between the sprue and the runner. So runner, there is a hollow portion cut off, right? So it is used for reducing the sand erosion from the bottom of the sprue. It is used, look at this line. This is used for reducing from the bottom of the sprue. Fantastic of you guys. That's nice. Rahul, Shambhu, Shubham, you guys are doing fantastic. So it is also made of the ceramic materials, it can be, and with a high porosity. So what happens, the molten metal, when it falls in this vertical chamber and it passes with a sudden change, then to a gradual reduction in its speed, it goes like this, correct? So here you have the splash core. What happens, the splashes that causes the erosion can be reduced. At the same time, it can filter a lot. So this will reduce the impact because it is traveling with such a high kinetic energy falling from a height. So definitely it is already that potential energy, it carries everything whatever you say, right? But at this point when it is of the highest level, with the height we are talking about, my dear people, the energy has to be reduced, otherwise the erosion will take place and automatically it disturbs the runner's profile. When it disturbs the runner profile, it affects the casting. So there are chances, correct? So to overcome this, we have the splash core. Understand this point, right? So this is what we call it as the splash core. Sir, what is next to that splash core, sir? We have the runner, sir. So it is a horizontal member with a trapezoidal cross section. Trapezoidal cross section, and it is the connecting passage between the sprue and ingate. It connects the sprue and ingate, we can say. That's all, sir? No. It is mainly used for reducing the sand erosion. We know that if this is the cavity, I can pour in like this too, correct? I can pour in like this too. We call it as a top gate, which we are going to discuss in the session. But when you have the top gate that fills up a cavity, there is a restriction. Above a 200 mm height of the mold, you cannot use a top gate. So sand erosion will be higher. So to overcome this, we bring up, along with the sprue, the runner. So it reduces the sand erosion. This manner I am talking about. So the sand erosion Also, to be reduced between the sprue and the runner, we introduce a splash core. So that is a different presentation. I hope you all are clear with it. Can I get a quick thumbs up from you all to make me understand, yes, you all are following the class, right? Thank you. Followed by skim bob, sir. Skim bob you can see in the previous figure here. You can see a hollow section which is not here. But this is how we see the diagram. But this is how much the detailing would be on your diagrams. Okay, please make a note of it. Okay, so what happens with the skim bob? So tomorrow will be a class mostly completing the gating and followed by few numericals. I can guarantee you with that. So don't forget to connect in that class. So I have to confirm with you that we have a session tomorrow for sure. Okay, for sure. It will be around the morning 11 o'clock, I would say. So I have to reconfirm this here, my dear people. Take a good note of it. So what is the use of skim bob, sir? Skim bob, it is a semicircular cut in the runner on the top and bottom, which helps in collecting the lighter as well as the denser impurities in the molten metal before it enters the ingate. Let me come back again with the written statement. It is a semicircular cut. Okay, it is a semicircular cut, my dear guys. I'm just looking at the messages if there is any. Just creating that important line. Thank you for the messages. So it is a semicircular cut in the runner, helps in collecting the lighter and denser impurities in the molten metal. Okay, please make a note of it. In the molten metal. Okay, so this is the important point. And finally about the ingate, so it is the entry point. Okay, it is the last point of the gating system from which the molten metal enters into the casting cavity. Last point of the gating system through which the molten metal enters into the cavity. The molten metal enters into the cavity. So students, A of S is your area of sprue, A of R is your area of runner, A of I is your area of ingate. So that is a shortcut for it. Vivek Sir has a friend named Sri. So you can call my friend as Sri. He is my friend. Okay. Who stands near the gate? No. Who stands near the entry of the college gate, or whatever you can say. Every time Sri used to come before Vivekanandan Sir. So which means Vivek Sir's friend is Sri. You can remember the Sri for sprue, R for Ranna, and I for ingate. It looks so easy. Why it is to be concentrated much, sir? People, when we talk about the choke area, what is choke area? Choke area is a area that we include it into the mold filling time calculation to find out the time taken for the mold filling. So choke area is nothing but the minimum of cross section of the of the gating ratio. So what is mean by gating ratio? Let us understand. Gating ratio means, see, it is connecting terms, interconnected terms. So gating ratio means it is the ratio between the sprue to the runner to the ingate. How to remember this is runner? After sprue it is the horizontal member. The horizontal is always a runner only and not a riser, because a person who runs will be always on the horizontal platform. You can remember it in such an order. And this is the ingate. So you can remember the Sri who always stands. So choke area is nothing but of the three, whichever is the minimum cross section. Minimum of AS, AR, AI, which we are going to discuss in the upcoming classes. Here itself I have provided the hint that we are going to have such an interesting terms. Okay, so it is the proportion of the cross section areas between sprue, runner and ingate. That is what we call it as the gating ratio. Please make a note of it. Okay, great. So these are the terms I have to convey. So now let's move on to the classification of the gating system. Sir, classification of the gating system can be many types, right? It can be many types. But we are talking particularly about the two. Okay, it is all about the pressure above the molten metal in the pouring basin. How it is it pressurized or non-pressurized? I'm talking about the position of the ingate, the top or bottom or parting or step. So these are the major classification, guys. Kindly make a note. Okay, let's move on. So next half an hour will be more inclined towards these terms. Let's appreciate them, and we can even discuss about few of the formulas. Okay, let's discuss about them. So the formulas will be presented today. Please make a note of it in the class itself. So let's move on to the classification of gating system. Classification of gating system. Students, as I said, it is of two types: pressure above the molten metal in pouring basin, and also about based on the position of the ingate. On the position of ingate. So non-pressurized and pressurized gating systems. Okay, non-pressurized and pressurized gating systems. So based on the position of the in-gate, we have 4, which I just mentioned. Please make a note of it too. It's nice. Thank you so much. So top gating system. Next to that, it is your bottom gating systems. Third one is your parting gating system. And the fourth one is your step gating system. Okay, these are the classifications. I hope you have written them. So moving into the pressurized gating system concept, and we will complete the non-pressurized as well. So there is a hint for you, because I connected the choke area for the mold filling time now. When you prefer it is a pressurized or non-pressurized, it could be a question as well. So I'll present a example and let you know how one has to approach here. People who are listening to the session, my kind request, post a message on with regards to the subject, your opinions and any thoughts. I'm happy to connect with you. So this is about the pressurized gating system. Okay, so it is used for high reactive materials generally. Used for, few words about you will be really happy for me to understand, sir, which department, which you are, and which college, sir, you are from. One and only creations, you said. So used for highly reactive materials. Aluminium, magnesium, etc. Okay, so this is especially used. Sir, very simple. The top of the pouring basin is closed. Okay, the top of the pouring basin is closed. That's what I have to say. Top of the pouring basin is closed. Right, top of the pouring basin is closed. Sir, what does that happen if there is a closing of the pouring basin? Sorry, the pouring basin. Right, what happens here? So the pressure above the molten metal in the pouring basin is maintained at greater than the atmospheric pressure. Okay, then you call this gating system as just above. So it more than the written format, this will speak better. So it's always good to note down the terms. For pressure above the molten metal is greater than, not even equal to, just greater than the atmospheric pressure. In this condition, we say the gating system is a pressurized one. Okay, my simplest example would be, sir, thank you, sir. And which example can I bring here? Okay, I'll do this one. 3:1.5, 1:1, 2:1.5:1. You have to understand here, my dear students. You have to understand here, your gating system, in that your in-gate values, see the in-gate values closely. Is the in-gate value the highest than any other area of cross section of the sprue and runner? If you see particularly, no. Correct? Make a good note that, let me give one another example for our reference. Say 1:4:4, right? We can bring in 3:1:2. what you can see here, what you can see, the molten metal which enters, okay, the molten metal which enters the cavity through the ingate, and if the ingate value is comparatively okay, 4 we can say, is comparatively less. That's what I am presenting here, sir. These are area of the cross sections, area of the sprue, area of the runner, area of the ingate. So if the cross section area is say 3 to 2 to 1.5, got it? This is your ingate, this is your runner, and this is your sprue. Okay, sir. What happens here? The molten metal, amount of molten metal that passes through is higher, but here in the ingate, just before the ingate, can you see more amount of molten metal is trying to push in through the ingate, right? But only less amount can be passed through. So now what happens? It's more like a pressure situation created. I'm talking on the meaningful aspect, right? So this is to encourage you people to understand, okay? So whenever the area of C, in a simple note, if I want to say the area of the ingate is always lesser than the remaining two, or at least equal, but still lesser than the other two, okay? Even see here, equal to this, we can say 2:2. So here they are equal, but this is greater, correct? These two are equal, but this is greater, but still this is the least comparatively. So when your ingate is always of the least cross section compared to your rest, obviously the gating system is a pressurized one, sir. You can remember it like this: 10 people can easily enter through this sprue, sir. Now 10 people, because it's of 3 centimeter, okay, so some 3 meter. But now in the runner only 8 people can enter because it is reduced in cross section, and in the ingate only 4 people can enter, but there are 10 people pushing in. What happens? There is a pressure created, right? So this hint you can take in to understand, oh, whenever the ingate value is of the least or equal to, and then still the least or compared to the others, you have to say it is a pressurized gating system. Coming to the non-pressurized gating system, you can completely understand here. This non-pressurized, what is that, sir? The top of the pouring basin is first of all open. That is one way. And maintained at a atmospheric pressure. Okay. It is to be noted. I'm again telling you, if the ingate ratio is the least, it is pressurized. That's the meaning. Understandable, sir? Just remember how many people can enter it. So one and only Krishna, if you're still here, I'm glad to get a connection from you as a word, piece of word, if you got this idea or not. Okay, so with your words, I'm just presenting it. So for a non-pressurized gating system is where the atmospheric pressure, let me bring it into a new page. So a non-pressurized gating system, the top of the pouring basin is first of all open. Top of the pouring basin is open and the pressure is maintained at atmospheric pressure. So the pressure of the molten metal is equal to the atmospheric pressure and is open. Obviously this can be the situation, right, sir? So don't confuse this with the pressure die casting concepts. Okay, we are just talking about the gating system where the cross section is changing. Okay, we are not talking about the special castings and the metal casting and the permanent casting, the pressure die castings. No, that is one way of doing it. You are pressurizing the molten metal to pass into. There you have the hot chamber and cold chamber die casting. That's different, right? You can just take a note of it. So these are the two terms. So let me present it at 1:4:4. So this question will come in the examination. So which among the 4 gating ratios shows the system is pressurized or non-pressurized? Okay, like this you can see, or you can even say 1:1.5:2, 3:4:5. So of these, your ingate is the of the highest, correct? So it's non-pressure. See, through this only 3 members can enter through the sprue, but runner is ready to have 4. Now here 5. So even then there are 3 people coming in here. Now there are more chances for the material to pass through. That is the meaning. So there is an opening for it, right? Hope it is clear. So the gating system are preferably chosen as a pressurized for some following reasons. Let me mention it here. Please make a note of it. Right? Let me mention it. You can just please make a note of it. That is when the pressurized gating system is required for a highly reactive materials, your aluminium, magnesium, etc. And when there is a back pressure gating system required, and to increase the velocity of the molten metal. Look at this line. To increase the velocity of the molten metal, but without increasing the height of the sprue. Sir, how? What are you talking about? So definitely we know the end point when it comes through, just before the cavity, your kinetic energy to everything becomes 0 because it's just pouring in, that's it, correct? So this point is where we are talking about everything to become 0. So at this moment there will be a maximum of a velocity generated, right, for the molten metal. So that influences the mold filling time to be lesser. So it quickly fills up the cavity. So without restrictions, if you are increasing the height of the sprue, definitely it is easy for them to pass through, right? From a top floor, if you see, only to the ground floor the water can be coming at a high pressure, right, and very high force. You are getting the water, right? Even if there is a less water in some, it is more data towards the lower channel. So when the height is higher, you are definitely getting the benefits. But if you still have to have a challenging environment where the sprue has to be of a lesser size, but you have to increase the velocity of the molten metal for the complete filling. Otherwise, misrun would take place, right? Complete filling will not take place sometimes. So in order to overcome these things, what we have to do? Make the system pressurized. So to increase the velocity of the molten metal in the gating system, what we have to do? We have to go for that too without the increasing of the height of the sprue. Without the increasing of height of the sprue. Hope it is clear, sir. So would like to hear from you all for further discussions here. So please make a note. Sir, why you are talking about this? How do you say increase of the height of the sprue is going to influence the velocity of molten metal? The velocity of the molten metal is nothing but root over 2g into h of t. This h of t can be total height from the pouring basin plus the sprue, or it can be just the sprue also. So ht will be always sprue plus pouring basin in some situations. Put together you can call it as h of t or this alone h of t, depending on the data that is presented. So whenever there is a pouring basin value available, you have to consider this for the whole. Okay, so what is that mold filling times, or why you have so much of connection with the mold filling time? All these statements, right from the initial we are talking about the mold filling time. The time taken by the molten metal poured into the pouring basin to completely filling the cavity. The time taken for the molten metal from its pouring into the cavity, into the pouring basin, to completely filling the cavity. So when you pour in molten metal into pouring basin, just when it is being poured, to completely is the time taken between. Okay, the time taken between we are talking about. Hope it is fine. So this can be written as the volume of cavity, okay, volume of the cavity divided by the flow rate of the molten metal. Okay, So which is equal to Vc divided by the flow rate, Vc divided by A into V. That is nothing but volume of the casting or the cavity divided by the choke area into root over 2g h of t. See, AC is nothing but the choke area. We know what is choke area, the minimum of the cross-sectional area of the gating system. Right, I have just introduced the term. HT, we know what it is. Correct? So choke area is the same. And velocity of the molten metal, where V is the velocity of the molten metal that we have written in the previous page as well. I again told you that it depends on the height and everything. Correct? Please make a note. So here the formulas I have to present it for your reference, which helps you in your preparations. So there are 4 types of gating system we used to say. Okay, top gate. Students, I'm just giving a diagram here. This is how it will be. It is directly pouring into the cavity where your height of the mold is not greater than, is less than or equal to 200 mm. Okay, so your bottom gate is where such benefits you are coming in. So the benefits of the top gating systems, we have to say the pouring time, the mold filling time we are talking is the lowest. It can directly pass in you. There is no need for the runner because the runner is obviously going to reduce the speed. Correct? And in-gate is not directly separately required on the horizontal channel. It comes directly, it pours in. And these manufacturing of the top gate is easy. Sir, if you consider, this can be in the drag box and this can be just in the cope box. You can easily construct them. So manufacturing of this gating system is easy. Just writing it as GS, you write it as gating system. Manufacturing of this gating system is easy, and it cannot be used for filling of cavities with loose sand molds, because when you pour from a height, definitely when there is a loose sand mold, what will happen? Sand erosion will take place. To overcome this, we have to make it an ideal choice. So about 200 mm, the top gate is not used. Mold height, and for loose sand molds, top gate is not preferred. Not preferred. Whereas coming to your bottom gating system, it is like the usual diagram that we make. Okay, it is the problem here with it is, my dear people, it is filling against the gravity. Correct? Fills against the gravity. Against the gravity. Other one would be like it takes 2 times of it, the temperature, the timing. So it can be even sometimes your height of the mold and the height of the T could be same sometimes, right? So in this case, how it could be the gating system, we can say bring HM is equal to HG. Okay, HG can also be used here. This could be a H of G and H of T. Okay. So here the mold filling time is nothing but the usual one, AM into HM divided by AC into root over 2G H of G we write. Okay, for the gating system we can write even as H of T or H of G, that's fine. Here the mold filling time will be equal to, my dear students, okay, will be equal to, similarly if you write, it is 2 times of the area of the mold into H of G minus root over Hg minus Hm divided by AC into root over 2G H of G. So if there is a condition that your height of the gating system is equal to the height of the mold in this aspect, okay, in this aspect, you will get 2 times of AM into root over HM divided by AC into, this won't come at the denominator. This won't come at the denominator. root over 2 into G. Okay, this we will talk about now. First case, this is our second case, your mold filling time in the bottom gating system, T of B, and this is your T of A. Okay, let's bring the T of A unto a conclusion. If T of A is equal to, in T of A, okay, if H of G is equal to H of M, then T of A will become A M into root over H G into root over Hg, correct? Divided by AC into root over 2G into Hg. Or you can even write this as Hm also. Okay, I'll write it as Hm here. I'll write it as Hm. So what happens? Hm and Hm gets cancelled one root. So you'll get the answer as Am into root over Hm divided by AC into root over 2G. So you can see this could be a 1 dash. So equating 1 dash with the 2, you'll get that understanding. T of A is equal to 2 times of TB. Just see this. Here you have AM into root over HM, no? Here you will get AM into root over HM AC into 2 times. So it is 2 times of. So what is the conclusion? The mold filling time of A is you can see TA will be equal to, sorry, TB is equal to 2 times of TA, you have to write. Correct? This is the right term. So bottom gating will be always taking twice the time to fill the cavity than if it is filled with the top gating system. That is the meaning here, sir. Hope this is clear to you all. So this is what we called as the top gating and bottom gating relationship. TB is equal to 2 times of equations. If we equate both. So this is the 1 dash equation and the previous one is your second equation. If you see them, what the connection is between them. Okay. So this is the second equation. This is your 2 times. Hope it is clear. And just about the bottom gating, I have to share with you the points here. The parting gate and the bottom gatings, step gatings. Students, parting gate acts both as a top gate and bottom gate. It will be like middle. Here it will be top gate kind of. It pours from the top, and here it will be bottom. So what it means? Your mold filling time is between the top gate and bottom gate. It's higher than bottom gate but lesser than higher than the top gate but less than the bottom gate. So this is about the parting gate system, parting gating system. Okay, so here the mold filling time can be written as volume of for the first case alone, you can write as V max into AC. The second case it will become V of C divided by V average into AC. That's an average velocity because it fills against the gravity. And the last one we are talking about is your step gating. Students, more than the formulas, here what is the requirement for step gating is like this. Okay, it can be a top gate or a bottom gate, that's fine, right? So it fills from both the sides. For high, very thick components, you need 2 gating systems to pour in to fill it completely. So here the problem that comes here is lack of fusion leads to cold shed. Lack of fusion leads to cold shed. Please make a note of it. Okay. So your flow rate depends on the n number of step gates into the flow rate through each gating system. So your flow rate n number of step gates, flow rate through each gate. Okay. So here the defect you can see, this is called as the cold shut. Please make a note of it. So we are understanding that in the gating system how it should be. So the chances of the cold shut is more possible, how we should come out of it. So students, the next class will be on casting defects. I have to inform you with that, and more numericals are to be also presented. Okay, so I hope you all remember that one-on-one live mentorship is for the iconic subscription with these many number of sessions as mentoring every month you will be getting in. Like, total number of sessions will be there. You can split it up accordingly to your convenience. So progress report with your test results, analysis, and where you are in your preparation journey, everything will be tracked, and there will be a guidance provided to you guys for the iconic subscription. So make a note of it. So don't forget to use this code VivekGate20 to avail the maximum discount, my dear people. So if you are looking for an EMI option with 0% interest, you can even avail loan with no cost, and you can get all the approval in 2 hours, just 2 hours. The minimum paperwork, just on the phone calls you can gain all these points. So flexible tenures are there according to your convenience. So please make a note. Thank you for attending the session. Subscribe to the channel and click on the icon for your notifications, and do like and share with your friends. So thank you, students. Take care. God bless you. Valga Valamudan. We'll be meeting once again in one other session. Thank you.